On this at the end of the period yesterday.
Wait, wasn't there two?
There's two. You had two sheets you were working on. We're going to go over both of those. So we got physical or chemical property. For this first part, you just had to check off physical or chemical property. So here we go. Let me zoom in a little bit to get this to fit on one page. Excelente. All right. Let me pick a fun color to write with because I feel like we need something different than purple. We'll do purple. All right, so interested to hear what you guys said for these physical and chemical properties. So let's start with Riley. What did you say for red color?
Physical.
This is a physical property. Density. Zoe, what'd you say? Physical property. Flammability. Flammability, yes. That is a chemical property. How do I know it's a chemical property? Well, first of all, there's only two chemical properties. Remember what they are? Daisy? Reactivity and flammability. And that's one of them. Okay. All right, next one. Solubility. Raise your hand if you said physical property. Only one person. Raise your hand if you said it was a chemical property. It's about half and half. Probably because you may not know what solubility is. Thank you. Solubility, anybody think they know what it is? Yes?
Is it like something dissolving in water?
Solubility is the ability to dissolve. So then you have to ask yourself, if something dissolves in water, can you get it back?
Yeah.
You can. If I dissolve salt in water, can I get it back?
Yeah.
How?
Boil it.
Boil the water, and you can get that salt back. So, solubility is a physical property. Solubility is a physical property. Scout, what'd you say for reacts with acid? Physical, chemical?
I want to say chemical?
Chemical, because that is reactivity. Next one, supports combustion. What'd you guys say? Gavin? Chemical. Because combustion is burning, which is flammability. And there's only two chemical properties. Do you guys know what they are? Reactivity and flammability. Okay, good. Moving on. Bitter taste. Physical. Physical. Melting point. Physical. If I melt an ice cube, is it still H2O? Yes, it is. Yes, it is. It is still water, so it's just a physical property. Reacts with water to form a gas. That's chemical. You want to know why? There's only two chemical properties. Reactivity and flammability. Guess what the next one is?
Chemical.
Chemical, because it says reacts. Hardness is physical. Boiling point. Physical. If I take water and I boil it, is it still H2O as a gas? It is. Can neutralize a base. This is chemical. Because if you are neutralizing a base, it is a reaction. It's a reaction. That's why. Next one, luster. What is luster?
It's the shininess.
How shiny is it? That's a little Moana. Shout out right there. Anybody here see Moana ever? My niece looks like baby Moana. Looks like baby Moana. Odor. Physical property. Flip it over. Flip it over to the back. This side might have been a little bit harder. Element, compound, or mixture. So ECRM. Some of these may have been guesses. That's okay. So I have element, compound, or mixture. Trying to get this all on the same page to get everything on one page. So close. Close enough. Number one, sodium. What did you guys say for that? Sodium is number 11 on the periodic table. That is an element. That's an element. So what should have been E? Number two, water. Water is H2O. That's a compound. That's a compound. One of the common misconceptions about elements and compounds is if it's like natural or it comes out of an animal that it's like an element or a compound. Ariana, you don't? Mr. Durbin's got your back. So here we go. Next one, soil. Soil is a mixture. How do I know it's a mixture? You have to ask yourself, can you write a formula for soil? No. If there's no formula, you can't. It's a mixture. Coffee. Mixture. There's no chemical formula for coffee. Oxygen. Element. It is number 8 on the periodic table. Number 8 on the periodic table. And some of these were tricky. Alcohol. Who said mixture? Raise your hand. Who said compound? Okay, so it depends what you were thinking of, okay? Alcohol is really a group. It's a hydroxyl group, OH, on like methanol or ethanol or propanol. So what we were thinking here was alcohol as a compound. If you were thinking beer or wine, that's a mixture, okay? So it kind of depends what you were thinking in your head. So if you were thinking beer, wine, something like that, that's a mixture. If not, it is a compound. Carbon dioxide, compound, that is CO2. If there's 2 capital letters, it is a compound. Cake batter. Do you like cake batter before you bake it? Yeah. Is cake batter or cookie dough better raw? Who said cake batter? Okay. Brownie batter. Anybody here eat like gluten-free stuff often? Brownies are one of the best gluten-free desserts you can have because there's not a lot of flour in them. Cake batter is a mixture. Air is a mixture. It's a mixture of a bunch of, there's compounds in it, but there's no formula you can write for air. Soap. Mixture. Iron. Iron is number 26 on the periodic table. Fe. 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 Salt water. Mixture. That's just salt and water. There's no chemical compound you can write for salt water. Ice cream. One of the tastiest mixtures. Do you guys ever have just ice cream for dinner? Yeah. It's okay to do that sometimes. I think it is. Breakfast? That's savage. No, I'm kidding. It's fine. It's fine. It's fine for any meal of the day. Just depends like what you're feeling. Pizza for breakfast? That's good. That's good. Nitrogen. Element. That is on the periodic table. That is number 7. Number 7. Eggs. I'm glad you did not say that's a compound. Even though those come out of a chicken, does not mean it is a compound. What about blood? Blood is a mixture. There is no chemical formula for blood. What does blood have in it?
Cells.
White blood cells, red blood cells, oxygen, platelets, water, iron. It's a mixture of a bunch of different things. You cannot write a chemical formula for blood. If there was a chemical formula for blood, would we have to donate blood? No, because you can make it.
We can.
Right? We can't make blood. That's why people have to donate. That's why it's a mixture. It's a mixture. There's different types of blood. Anyone know their blood type?
Type
Nobody.
I don't know what that means.
That is a type.
Positive. What's
O positive is not a type.
Wait, what's the difference?
So the different types of blood, are depending on the antibodies on your blood cells. So that is based off of if I'm type A and I'm in the hospital and I need blood, then I can get type A from Caden if he's type A, or I can get type O from Willie if he's type O, because A matches me, O is a universal donor. So it depends on the type. What?
Do you know the difference?
There's A, there's AB, and there's O.
Oh, like,
I think it's A, AB. A, B, or O. I don't know.
is there a difference? Like,
Which one?
It's just the antibodies on the cells. So it's like, will they accept other cells? You'll learn all about that in biology. Yes?
Which one means that you have like bad blood?
None of them, but there's a song about that. It's called Bad Blood.
Oh,
Yeah. None of them are bad blood. All blood is good. It just, whatever you are born with is the blood that you need.
What happens if you put a different one? Yeah.
I'll try to remember that. Yes?
What happens if you get mixed with another blood?
If you are given blood that your body cannot accept, your body's going to see it as like an intruder, and it's going to attack that blood.
That's why I'm say bad blood.
If you ever have like a blood cancer, which hopefully you never do, like leukemia, It's where your body, there's cancer cells in your blood and your body starts attacking it. So, it's not great. Table salt. That's a compound. That's NaCl. Two compound, two elements together. Nail polish, mixture, milk, cola, all mixtures. What about orange juice? Now, don't get confused. OJ is not the chemical formula for orange juice. All right? What? I don't know. I just thought that was funny. It's just a shorten. It's orange juice. Helium, element, methane, CH4. Therefore, it is a compound. It's a compound. It's a compound. Cool? Let's look at the front of the other one before we get to today's activity. That says physical and chemical changes. We're going to save the back of the other one for a little bit later. So we're trying to get ready for our lab on Friday. Here we go. I think I can put this all on my page. Yes? Mr. Deverin's got your back. Okay. Salt dissolves in water. Physical or chemical change. First of all, a physical change, I can do what? I can undo. I can get it back. A chemical change, it's permanent. I cannot undo it. So here we go. Salt dissolves in water is a physical change. Hydrochloric acid reacts with magnesium to produce hydrogen gas. Chemical. Chemical. Piece of paper, a piece of copper is cut in half. Physical. It's still copper, right? Yeah, just copper cut in half. Speaking of copper, last night my toilet handle broke. My daughter's just like, hey, the handle doesn't break. So then I had to buy a new toilet handle. Anyone here for fix a toilet handle? It's not very hard. Buy one, you kind of like slide it in and then you like cut it to the right length and then it just pulls it up and done. $9 at Lowe's.
Nice.
If you need me to fix it, I will only charge you $50. So, pretty good deal. Cheaper than a plumber. I'm serious. That'd be like $150 if you called a plumber to fix that. So, if you need your toilet handle fixed, let me know. Okay.
I'll call you for $50 to tell me how to do it.
That's just for me to tell you how to do it. For me to fix it, it is the $100. Still cheaper than the plumber.
Yeah.
Or you can just look it up on YouTube like I did. Guys, you know that YouTube has pretty much anything. If there is something you need to fix, I just looked up how to fix a toilet handle on YouTube. Boom. So the handle, the thing that was attached to the thing that lifts up the thing to drain it, it just broke.
Oh, like snap it.
It snapped.
Oh.
So, super easy. How do we get on that? Copper. Oh, it's because the one I had in there was plastic, so I replaced it with, I'm guessing it was copper. The handle was copper. Okay. Sugar cube is ground up. Physical. Physical. Water's heated and changed to steam. Any phase change is always going to be a physical change. Because I could get that water back. How can I get the steam back into water?
It'll like drip down.
How? That's called what? Condensing it.
Precipitation.
Condensing. That's also rain. Speaking of rain, are you guys keeping up track of what's going on in the Gulf of Mexico?
What's that?
Tropical depression Helene is getting ready to form into a really powerful hurricane today. It's going to hit Florida. So,
That's usually average for
what?
weather. Isn't that tornado?
That's a hurricane. They think it's going to be at least a category 3. There's a what?
King tide.
King tide.
What's that? It's like where it's the tide so high it takes like hours.
Yeah, I just saw another house. They lost another house. So I saw a video of that the other day. Okay. Iron rust.
Chemical.
Chemical. Once something starts rusting, we talked about that, right? It's just a continual process. Ethyl alcohol evaporates. Physical. That's a phase change. Ice melts. Physical. Milk sours. That's chemical. Once your milk sours, you cannot get it back to good tasting milk or good smelling milk.
Cottage cheese.
It's kind of turning into cottage cheese. Yes. You guys know that like cheese is just like aged milk, right?
Wait,
what?
It's disgusting.
Oh.
Cheese is just kind of like aged milk.
Oh, well, I'll
Well,
eat
you never
that.
cheese
That's
your meat,
pasteurized.
Oh, I still eat that too.
I don't even like milk.
I used to like cottage cheese for a second, and then I did.
I still like
Disgusting. Disgusting. Sugar dissolves in water.
this.
Physical. Physical. Sodium and potassium react. Do you know why that's a chemical?
And it says
Because it's
potassium.
reacting.
Because there's only two chemical properties.
Potassium.
Reactivity
And
and inflammability. It's almost like you're going to need to know those for the test eventually.
Oh, yeah.
Okay. Pancakes cook on a griddle.
Physical.
Chemical.
Oh.
You cannot get pancakes turned back into batter. You've had a chemical change. Caden, what's your question? What's your question?
Oh, no, I'm good.
Okay. You just said I'm lost, and now you're good.
Yeah, I'm good.
Okay, so you're not lost. Okay. Grass grows on a lawn. This is the trickiest one on here.
Physical.
How does grass grow?
Through the ground, so if you cut it, it'll be shorter.
But how does it grow?
it's just a cycle.
Through the
so it'll
sunlight
grow
and
again.
water.
So you're telling me that it takes sunlight,
It's physical,
it takes sunlight, and it takes CO2
and it takes dirt.
plus H2O,
Left.
and it turns into C6H12O6 and oxygen. What is that called? Photosynthesis.
So in the
What'd you say,
process,
Cole?
it's going to-
That's a chemical process. Grass growing. So while it's just grass growing into longer grass, in order to make that happen, that's photosynthesis. That's a chemical process. That's a tricky one. Tricky one. A tire is inflated with air. Physical. Just a not flat tire to a fill tire. Food is digested. That better be chemical. You don't want that back after it's digested. Think about that. Water is absorbed by a paper towel. Physical. Good. Ethyl alcohol boils. Physical. Because boiling is a phase change. It's just going from a liquid to a gas. Ethyl alcohol boil. Oh, we just did the one. Paper burns. Chemical. Water freezes.
Physical.
Physical. Fireworks explode. Chemical. Alka-Seltzer gives off CO2. Chemical. Clouds form in the sky. Physical. So, remember, cloud forming in the sky is just water vapor. Just water vapor. So, we're going to be using in lab on Friday. We're going to do that later because I want to get to the prep for our lab Friday. Physical properties and physical changes to separate a mixture. So take a look at what you picked up on the way in. Take a look at what you picked up on the way in. On the way in, you picked up a piece of paper that looks like this. It says, using the following data, write in paragraph form, and I think it's going to be better just to do step by step. Let's work through this together. How you would separate a dry mixture of steel shavings, styrofoam, sugar, and glass powder. You must use evidence from the data table to support each step of your process. You have available the following: beaker, hot plate, water, spoon, stir rod, magnets, tweezers, Erlenmeyer flask, ultraviolet light, filter paper, funnel spoon. First of all, this is just like lab. There are more materials provided than you need. Which one of those materials can you probably guess you are not going to use? Do you see anything about ultraviolet light in one of these physical properties? I know I'm not going to be using an ultraviolet light. I'm crossing that out now. Okay? That's garbage. Now, what will I definitely probably use? Why would I use magnet? Because I have right here the physical property of magnetism. Is it attracted to a magnet or not? So I know I'm probably going to use magnets. What else? It is soluble in water. What does solubility mean?
So you need to stir it in the water.
So that means it will do what in water? Dissolve. That also means if it's soluble in water, it will go through a funnel. So a funnel will not catch it. A filter will not catch it if it's soluble. So what am I probably going to use for solubility? Which materials?
Water.
Water. I might need a spoon.
Stir rod.
I might need a stir rod. I'm going to need a filter paper, Paper. I was thinking filter paper and funnel at the same time.
What about a beaker?
Funnel, and I'm gonna need something to catch it. Probably an Lindemeyer flask. Yeah, I'm gonna need a beaker too. Okay.
There's 2 spoons on there.
Well, just because.
And
You never know. Density. What am I gonna use the density for? Am I gonna use density? Someone says yes. Caden says yes. Why?
Because you gotta get the density before you solve the answers. And actually, no word is all the math.
Remember, my goal is to get this mixture separated. What is the density gonna help me separate?
The weight.
Look at your data table. Look at the densities. What will the density help me separate out?
your steel shavings,
Could be steel shavings. Why?
because they're in the heaviest, so they'll sink to the bottom.
Steel shavings would sink. That would be one way. But what else, Lyra?
The styrofoam?
The styrofoam. How would that help me? Does yours say styrofoam or wood shavings?
Word shaving.
Where does it say? Oh, sorry. We're supposed to look here. There's not styrofoam. It's wood shavings. That's a typo. So which of these 4 things could density help me separate out?
Shavings.
Why the wood shavings?
Float to the top.
How do you know wood shavings would float to the top?
They have a density less than.
Yes, their density is less than 1. So if I pour water in the beaker, where's my wood gonna go?
Up to the top.
To the top. Okay, you guys see what we're doing here? Okay, boiling point. Why does that matter? Caden.
You have to boil the water so that we have no salt into it.
So if I boil the water, right? Water boils at what temperature? 200 and, it boils at 100, right? 100 degrees Celsius.
Yeah.
So will my sugar boil away with my water?
No.
No, because sugar doesn't boil until 146, right? Yes? So my water will boil away, and what will I have left? Sugar. So, take 5 minutes. Try to write a little procedure on how you guys would separate this mixture. We just kind of talked through it. Okay? Write like at least 4 steps. What would make sense? There's no right or wrong answer. There's about 10 different ways you could do this. But take a couple minutes and write a procedure on how would you separate this mixture based on what we just talked about. Should we do step 1 first together?
Yeah.
Okay. Let's do step 1 together. Step 1. What do you guys think step 1 should be?
Pour the water into.
I think it'd be easier to save the water even before. You can do something even easier before you add the water.
The magnet.
Use the magnet. Yes. Use the magnet to get steel out of mixture, comma, because steel is magnetic. Steel is attracted to a magnet. So do you see how I said what we're going to do and why? Yes? Okay. Try to come up with step 2 on your own now. So I've got the steel out. All I now have is a dry mixture of wood, sugar, and glass. So try to come up with step 2, 3 on your own. I'll give you guys a couple minutes to write this out. Try to figure out what your next step is going to be. So what are you going to do and why? Talk about the physical properties. Yes. It dissolves. If something is soluble, that means two things. First of all, if you add water to it, it will dissolve into the water. Second of all, it will go through filter paper. It will go through filter paper. If something isn't soluble in water, if you pour that into a filter, guess what the filter is going to do? It's going to catch the thing in the filter. Okay? So if something isn't soluble, the filter is going to catch it. If it is soluble, it's going to go through the filter. It's going to go through the filter. Okay, you done? Whole thing?
How many steps did you say?
I think you should have at least 4. There's 4 things you have to separate out, so there should be at least 4 steps. And there could be more than that.
Would the sugar boil with the water or not?
The water boils at 100, right? So if you boil water, the sugar is going to be left over. Because the sugar doesn't boil till 146.
What about the glass fire? If that would
Glass doesn't boil till 1500. So if you boil water, the glass powder will not boil. And like I said, there is no one correct way to do this. There's different orders you can do it in. Give you guys a couple more minutes. Yes.
wait, so what is the boiling for?
What's that?
What's the boiling for to get the sugar?
What's the what for?
The boiling
The boiling point. So that means if I boil water, right? Water boils at 100 degrees Celsius. So the water will evaporate. Anything that's above 100 degrees Celsius will remain. That's what that's saying.
Wait, what's a glass powder again?
It's just crushed up glass. Glass pieces. And like I said, there could be multiple correct step 2s. Depends how you guys do it. Got leftover pizza for lunch and chips. And I got a Coke to go with that. Ice cold Coca-Cola.
No longer live.
Sometimes I just want a dark pop. We got it? Would somebody like to volunteer their step number 2? Sawyer.
Run it through a filter to get the wood and glass powder out of it, because they're both not soluble in water.
If I pour this into a filter, everything's going to get caught in the filter. You forgot a step. You can't run something in a filter yet.
Oh. Never mind then.
You're kind of on the right track, but you'd have to have something before you run it through a filter. So right now, if you say run that through a filter, I pour that in, I have sugar, I have solid sugar, solid steel, solid glass in the filter.
Oh.
Do you have a guess of how to fix that?
Add water to it, right?
Add water. Did anybody add water for their second step? Okay. I would add water. I would add water for my second step. Did anybody not add water? Okay, add water. What is going to happen once I add water? Yes.
Your wood would float to the top.
Yes. I would say scoop wood off the top because wood has a density of less than 1. Swear, does that make sense? You could put the wood and steel in, but it's going to be really hard to separate the wood and steel if you don't get the wood off at the top first. So I said, what I'm going to do is scoop the wood off the top, and then why? Because wood is a density of less than 1. So far, what have I separated?
The steel.
Steel's already out, right? The magnet. The wood's gone. So what do I have left in my beaker?
The glass and the sugar.
I've got water with what in it? Glass and sugar. I've got water with glass and sugar. Lyra.
Filter it. Or do you guys do that?
No, we did not. So you are saying pour the remaining mixture into a filter? Okay, let's try that. So pour mixture into filter. What will go through the filter? What is the filter going to catch? Now, Sawyer.
The filter's gonna catch the glass powder
Why?
because it's not soluble.
Yes. I would say the filter will catch the glass powder because BECAUSE, it is not soluble. Did anybody use glass's density to help separate it? Because once I added the water, think about this. This would be another way you could do it. I added the water. I scoop off the wood. Where's the glass at now? In the bottom of the beaker. What if I would have just poured that liquid slowly through the filter? Where would the glass powder end up? In the bottom of the beaker, right? Would that be another alteration of this you could have done? Because the glass sinks. That's another way you could have separated it. Okay, so I poured the mixture in the filter. The filter will catch the glass powder because it is not soluble. What is going to go through the filter?
Sugar.
The sugar water, yes. So step 5, sugar water goes through filter. Why?
Soluble.
Because sugar is soluble. So I'm going to say sugar water goes through filter. I got to move mine up. Are you guys caught up? Can I move mine up? Okay. We're going to catch up at step 5. Step 5, I'm going to say, I'm just going to leave this here. Step 5, sugar water goes through filter because sugar is soluble. Okay. Have I separated everything out yet? No. What did I catch in my flask underneath it? Now my flask has what left? Sugar water. Ariana. Heat the flask. Yes. Heat the sugar water till water boils. Then what will happen?
It will settle.
What will I have left?
water.
I'll have sugar left, right?
Oh,
The
yeah.
water's gonna boil, right? The sugar will remain because its boiling point is what? Is, you could say 146 degrees Celsius, or you could say is greater than water. Either one of those, yes.
Okay, how do you keep it from like reaching 146 if you're boiling? Because one of the things I get to boil.
So the water boils at 100, right? As long as there's water there, we're going to talk about this next chapter. The water stays at 100 degrees Celsius. It's a constant temperature. That's a great question. How does it not keep heating up? Now, if I would leave that flask on there and just have the sugar, it would keep heating up, and that sugar would eventually melt and crystallize, but we take it off before then. And you get to see that in lab. It's super cool. It's not sugar in lab. It's something different. You'll see the crystals reform. It's really cool. It's really cool. So we said heat the sugar water till water boils. The sugar will remain because its boiling point is greater than water. Or you could say its boiling point is 146 degrees Celsius. On Friday, you will have a different mixture than this. And you're going to have to do this exact thing. So you and your partner are going to have to separate it out and write a procedure based off of the physical properties. Does that make sense? We're going to be doing on Friday.
So we won't have this and then.
It's a different mixture than this. Similar idea, but different things. Yes?
So do we get like